But as with Jupiter's other moons, there was a further mystery. This much volcanic activity requires an immense amount of heat. But where had it come from? Io, 800 million kilometers from the Sun, should be too cold, but clearly it wasn't. Could the answer be gravity? Jupiter's gravitational field keeps Io in orbit, but as it goes around, it passes on the inside of Jupiter's other moons. Their gravity pulls Io in the opposite direction. That distorts Io's shape. It's the distortion that creates the heat.
As Jupiter's large moons orbit around the planet, they're pulled and pushed and squeezed as they go around in their orbits. And this creates heat, friction, and causes melting within Io of the rock to power its volcanoes.
It raises tides on Io, very much like the moon raises tides on the oceans on Earth. Only on Io, the whole surface goes up by over 300 feet. Can you imagine what it would be like on Earth, like here in Los Angeles, if the crust of the Earth was rising 300 feet?
It was an astonishing discovery. A world pulled apart, shaped by violent forces. Yet, as amazing as it sounds, of all Jupiter's moons, Io may not be the strangest. The next moon on Galileo's path was Europa. Its surface is covered in strange geological shapes and parallel tracks that cut across the ice. It's an ice world with an extraordinary secret. Could it harbor the ingredients for life? Images of Europa from earlier missions reveal a pinkish-white world. But Galileo found fewer meteor craters than expected. That meant something was erasing the craters after they formed. Because Europa's surface is ice, scientists believed water could be welling up from below. This moon was so intriguing, the team wanted a better look. But to do so would mean spending more time at Europa than planned.
The original schedule called for only 3 flybys of the moon Europa, but the evidence was so compelling that it compelled the mission to be extended in length and to go back several more times.
Galileo's first job was to image the moon in greater detail. The question was, how active is Europa's surface? Are the processes that erase impact craters fast or glacially slow? The team began by assuming the process could take billions of years. That assumption changed fast.
I'm listening to them discussing the age of Europa's surface dropping. Oh, well, maybe it's a couple billion years old. And then the next flyby, well, it might even be 100,000 years old. And then the next flyby, it may be currently active.
While measuring Europa's magnetic field, Galileo uncovered another mystery. As the moon orbits Jupiter, its magnetic field shifts. Europa must have a conductive layer which allows Jupiter's magnetic field to pass through it. There is only one thing that could have caused this, and it was a big surprise for the Galileo team.
We were able to interpret these signatures as being produced by a global ocean beneath the surface of the ice.
Scientists believed Europa's ocean was vast, covering the whole globe to a depth of 160 kilometers, making it the largest body of liquid water in the solar system. If this was the case, the team would first have to address a fundamental problem. Europa's surface temperature can reach -93 degrees Celsius. Why doesn't such a huge ocean so far from the Sun freeze? Astronomers thought the answer to this question might be the same one that drives the volcanoes on Io. Jupiter's gravity stretches and compresses the moon, creating heat within. It's the heat that keeps the surface in constant motion. This could also explain some unusual features found on Europa.
Galileo images showed that ridges crisscross the surface of Europa. These are bizarre features that travel across the surface for up to 1,000 kilometers, and typically in pairs. That is, a ridge with a depression in the middle and another ridge. These are bizarre features like nothing we see on the Earth.
At first, these ridges were a puzzle, but researchers soon came up with a solution. Planetary scientist Bob Pappalardo reproduces the effect with ice blocks in the lab.
As Europa is flexed by Jupiter's gravity, its surface bends and cracks and makes fractures through the ice. Well, as it's squeezed and bent, the ice slides back and forth along these fractures. Now this can create heat as these blocks move by one another. And that heat can warm the ice on either side of the block, and that warm ice rises up to form these strange ridges that we see, these tracks that seem to go across the tundra of Europa.
Galileo revealed a world in constant motion, evidence of heat hidden below the ice. Flows of material on the surface are possible evidence of ice volcanoes or geysers. Brown-red stains stretch across the ice, where it's cracked open, and salty material from the interior has welled up from below.
We see pits and spots and domes on the surface of Europa that might be related to the rise of blobs of warm ice that move up through the shell, sort of like a lava lamp.
Heat from the interior of the moon may even drive hydrothermal vents in the ocean. On Earth, hydrothermal vents on the sea floor are hotspots for life. Galileo's data also suggested there's carbon dioxide frozen on Europa's surface, possibly welling up from the ocean below. If so, the find was huge, because carbon dioxide is vital for life. Does this mean there's life on Europa?
I'm in the camp that where there's water, there's a very good chance that there's life, and where there's materials for that life to use. And on Europa, we seem to have the materials and we have the water.
If we search and find life within the ocean of Europa, that'll be an enormous leap in understanding whether we're alone in the universe or whether life may be everywhere.
The search for life is an irresistible lure. Scientists are desperate to go back to Europa. Near the end of the next decade, they hope to launch a groundbreaking mission to orbit the moon. The Europa Explorer will take the first steps towards answering the biggest question of all: is there life on other worlds? It will survey the ice on Europa's surface. As well as analyzing its structure, it will search for spots where we could one day break through to the ocean beneath. The Explorer's main tool is radar. It will give scientists a three-dimensional map of Europa's crust. This will tell them just how thick the icy shell is.
How far beneath the surface the ocean is, if it's a global ocean, how deep it is, how thick the ocean layer is.
These are crucial questions. Once scientists know how thick the ice is, the next step is to work out how to get beneath it, and that will mean a completely new mission. A probe that will not only orbit Europa, but land and explore its subsurface ocean. A robotic submarine, Endurance, is already at work in Antarctica. It's the first of a new breed of underwater probes that can also operate under the ice. The aim is to create a vehicle that needs no instructions from home. Endurance must make decisions all by itself. Perhaps one day a vehicle like this will search for life on Europa. But first, it has to get through the ice.
That thick ice cover, it takes a lot of energy to melt ice. People don't usually appreciate that. But we'll need some kind of nuclear system that will melt that ice, and it will take weeks, perhaps months, to get through that ice.
We might imagine a lander spacecraft that melts its way all the way down to the ocean and explores what's really down there.
The discovery of life on another world, would be one of the greatest finds of all time.
If life exists in the ocean of Europa, that would tell us that life probably exists almost anywhere there's a water-rich environment. That would be an amazing discovery.
Jupiter and its moons have already transformed our understanding of our place in the solar system. Now new missions to Europa may finally prove that life on Earth is not unique. And if there's life on two worlds, then why not on many? Jupiter and its moons may one day give us hope we will find not just life, but intelligence out among the stars.